picked up the chemical signal, which were the neurotransmitters. Then that information was given to cell body processed what occurred. And then remember, axon was supposed to, the conducting one, they're supposed to convey that information to the next neuron. Therefore, the electrical impulse starts on the axon HeLa, arrives at axon terminal. As soon as it arrives at the axon terminal, basically that signal is converted into a chemical one, which is release of the neurotransmitter. Okay? Remember over here, I whispered, they all whispered, going from this one to this one, they basically caused the release of the neurotransmitter, right? They had sent the note over. Does that make sense to you guys? Do you guys get the whole picture? Okay? One axon releases a neurotransmitter binds to the cell body. That information is conveyed, again, into electrical impulse, which occurs. Then that electrical impulse will cause the release of a neurotransmitter, so then that neurotransmitter can go bind to the dendrites of a next neuron in turn. Okay? Make sense? Okay. Now let's talk about resting membrane potential. -70. So this right here is the resting membrane potential. What does resting membrane potential mean? What does that mean to you? What does the name indicate?
There's no conductivity.
So that's true, but what is the charge, or what is the voltage on the axon or on the neuron when it is not conducting any action potential? Does that make sense? So during rest, when the neuron is not conducting any action potential, what is the charge of the axon? Okay? Which is -70. Okay? So -70 is the resting membrane potential. Means what is the charge on the neuron slash axon, because that's where action potentials occur, when the neuron is not conducting any action potentials. Okay? So it's like saying, what is a person's heart rate when they're not exercising? Does that make sense? Okay? What is a person's normal heart rate when they're not exercising? Because as you know, when you exercise, doesn't your heart rate increase? Right? Any action potentials?
Can you repeat the meaning again?
I'm just saying that what is the charge of the neuron when it's not conducting any action potentials? Now we have threshold. Threshold is C, okay? Which is -50. Threshold is this dashed line. Okay? It's that dashed line. It is a value of -50 millivolts. Meaning, what does threshold mean to you guys?
What about?
Yes, so threshold basically it means the minimum amount of voltage needed to generate action potential. Minimum amount of voltage needed amount of voltage needed to generate an action potential. So it's -50. So it's like saying, okay, here's a student, right? If I keep on tapping her, at what point has she reached her max and then she snaps back and hits me back? Does that make sense? I'm a teacher, so her threshold is high, right? She's not going to come and snap me back. But what if her friend kept on doing that, right, during the movie? And she's like, stop it, let me watch the movie, right? Isn't that the threshold? At what point will you now excite or fire? Okay? So this is negative 50 is needed for action potential to occur. Before then, action potential will not occur. That's what threshold means. Now, graded potential. I'm coming to graded potential. Graded potential is summation of multiple neuronal outputs. Okay? So basically, let's say I have one neuron right here, another neuron, and I have, so here's the axon terminal, and here is the dendrites. Okay, and here is the synaptic cleft. Now, this axon gives a signal which is positive, meaning it tells this next neuron in line to fire. Okay? This one gives a negative signal, meaning it tells this one not to fire. Don't they cross each other out? Right? So positive one will be balanced with a negative one, right? So right now, this axon is not doing anything because it got stimulated, but then it got inhibited. So doesn't the outcome of this one determine what's going to happen? If this gives a positive one, this one will fire, correct? If this one gives a negative one, this one won't do anything, right? Do you see you have, it's a summation of multiple neuron outputs? That's what gradient potential is. Does that make sense? Yes? So this one gave a positive, it was about to fire. Then this one's like, no, it did not fire. Now this one, if it gives a positive, this one will fire, actual potential. If this one gives a negative one, it will not fire actual potential. So gradient potential is a summation. Remember the resting is negative 70? Remember the resting membrane potential was negative 70. Basically, you need negative 50 to hit actual potential. So this part right here is a gradient potential, that time point in the middle where it's deciding, should I fire, should I not fire? Does that make sense? Yes? So B would be gradient potential. Now, you have two types because you have a positive signal or you have a negative signal, right? Depolarization is a positive signal. Okay? Hypopolarizing type is a negative signal. So the membrane is right here. Okay? If I give a depolarizing type, does the membrane go towards threshold or away from threshold? If I give a depolarizing type of a signal, does the membrane go this way or does the membrane go this way? It goes towards. Okay? You can't say up or down, it goes towards threshold. So depolarizing is a positive signal. The resting membrane potential goes towards threshold. Okay? Hypopolarizing type. It's a negative signal, so the resting membrane potential goes away from threshold. One, the arrow is going towards threshold, the other one, arrow is going away from it. Okay? Does that make sense? So if somebody wants to leave the room, they have to cross the door. Their threshold, they have to reach the door, correct? And then they could exit. So isn't this from this place to this place, isn't that gradient potential? Okay? If on my back is turned, if he or she is leaving, right, they can leave. But while they're trying to sneak out, what if I turn around? I'm going to stop them. They came this far, but I could stop them. Like, where are you going? It's not time to leave yet. Please go sit down, right? That is a gradient potential going from her seat to the door. Does that make sense? Okay? What would be a positive signal? Okay, her friend sees that she's leaving, so her friend comes up to me, keeps me preoccupied, so I don't notice that she's leaving, right? But some other students, it's like, hey doc, somebody's leaving, and I turn around, right? That's a negative signal. Does that make sense to you guys? Okay. Now, depolarization. It's the first phase. It's the upstroke. As you can see, this is the upstroke. Okay? So it's D. Okay, depolarization is the first phase of action potential, and in the image, it's the upstroke. Would you say the cell, the membrane, is it getting more positive or more negative?
Positive.
Positive. Okay. Cell becomes positive or more positive due to influx of sodium. This is due to influx of sodium. Repolarization is the second phase. It's a downstroke, as you can see in this part of the graph. Okay. Going down. So it's a cell, so this is E. Is the cell becoming more positive or more negative?
More negative.
Negative. This cell is becoming negative due to efflux of potassium. Potassium is leaving the cell, therefore the cell is becoming more negative.
Influx of, I'm sorry,
Not influx,
or
efflux.
efflux of
Potassium.
potassium.
K stands for potassium. K stands for potassium. And A stands for sodium. Now, hyperpolarization. It's the last phase, or the last. This part of the phase is below, it's this part. It's below the resting member potential, correct? The wave is underneath the resting member potential. It's due to efflux of potassium. It's due to efflux. Efflux means exit. Influx means entry. Influx, coming in. Efflux, exiting. Okay, and it's due to potassium. Okay, any questions so far? Yes.
So repolarization and hyperpolarization are both due to the efflux of potassium?
Yes. Repolarization and hyperpolarization are both due to efflux of potassium. Now I know you're wondering why is it called differently if it's the same. Well, right now I would say it's because, what does hyper mean? More. You started out at -70, okay? You went up. That was depolarization. Then you came back down to resting member potential, which was repolarization. But you did not stop there. You even went beyond. This is why it's called hyper. It's repolarization still, but it's hyper. It's even, the membrane even becomes more negative than where you started off. Okay? And in physiology, you exactly learn why you don't stop there, why you continue. Does that make sense? Okay. Okay, this slide is for you guys to, it's the same stuff. I gave this empty slide, so once you have studied stuff, use this one to test yourself, okay? Okay, take a 5-minute break. I'm going to open up the new PowerPoint, and then it's going to be